In section 5.4, which is called the exponential function, we're going to differentiate and integrate a natural exponential function today. And what natural exponential function is y equals e to the x. E being the natural number that occurs with the natural log. So the definition of y equals e to the x is if and only if x is equal to ln of y. So we know the derivative of ln of y. So we're going to use that to find the derivative of e to the x today. But remember, since these two are inverse functions of each other, ln of e to the x is just x because ln and e's cancel out. Remember, they're using the log power rule for a log would be to bring down the x, and the ln of e is 1, so 1 times x is x. So same is true for e to the ln of x power. E and ln, they cancel out and it just becomes x. So I'm going to prove this, we proved it in the class today, but the derivative of e to the x is just e to the x, and the derivative of e to the u would be then e to the u times the derivative of the inside, which is u, so we're using the chain rule right here. So then if the derivative of e to the x is e to the x, then the integral of e to the x dx would be e to the x plus c. And an integral of e to the u du then will be the e to the u plus c. So what I'm going to do is I'm going to use example number 122 in the section 5.4, and we're going to find a particular solution, f of x, for this function, which is the second derivative of the f of x. So remember, we are going to integrate this. So I'm going to rewrite this and say f prime of x is equal to the integral of sine of x plus e to the 2x dx. Because we're going to find the antiderivative of double prime, which is single prime. And that is equal to, I'm going to separate this into two parts. Well, sine of x dx plus integral of e to the 2x dx. Well, we know that the integral of sine of x dx is negative cosine, but this is the new part right here, where u is equal to 2x, and du would then be 2dx, and if I were to solve for dx, it is du over 2. So I'm going to do my u substitution here. Well, integral of sine of x dx is negative cosine of x, because derivative of cosine is negative sine, so there's my negative cosine of x, plus the integral of e to the u. When I do my u substitution, I'm going to put this back in, and then dx would equal du over 2. So then I could pull out the 1/2. So I get 1/2 integral of e to the u du is just e to the u plus c. So this becomes negative cosine of x plus 1/2 e to the u, which is 2x, plus c is my first derivative. Now, they've given us conditions here. It says when x is equal to 0, my first derivative equals to 1/2. So I'm going to solve for solve for c by plugging those facts in. So first derivative is equal to 1/2 when x is equal to 0. And cosine of 0 is 1. So this becomes negative 1. Plus e to the 0 is 1, so this is 1/2 plus c. And to figure out what c is, I'm going to have 1/2 equals negative 1 plus 1/2 plus c. This will be 1/2 equals negative 1/2 plus c. And when I add 1/2 to both sides, I get 1. C equals to 1. So f prime of x is equal to negative cosine of x plus 1/2 e to the 2x plus 1. Now we got to find the original function. So we're going to integrate. So then f of x is equal to the integral of negative cosine of x plus 1/2 e to the 2x plus 1 dx. And I'm going to separate it again like we did before. And we're going to integrate the negative cosine of x dx plus, I'm going to pull the 1/2 out and make it e to the 2x dx plus integral of dx. And integral of negative cosine of dx is negative sine of x, because derivative sine is cosine. And so I'm going to have that negative there, plus, same thing again, this is my u, and du would equal 2 dx, so then dx would equal du over 2. So I'm going to have the 1/2, and I'm going to do my u substitution, e to the u, and dx is equal to du over 2, plus integral of dx is just x plus c. So then when I finish this, I get negative sine of x, plus, I'm going to pull the half out here, so it'll be 1/4 e to the u, where u is equal to 2x plus x plus c, and that's my f of x. And they also gave us the initial condition for this, where when x is equal to 0, the function is equal to 1/4. So to solve for c, we're going to plug in x and set it equal to 1/4. So sine of 0 plus 1/4 times e to the 2 times 0 plus 0 plus c, and 1/4 is equal to sine of 0 is 0, and this is 1, so that is 1/4 plus c, so c has to equal, when you subtract, 0. So my final function, f of x, is equal to negative sine of x plus 1/4 e to the 2x plus x, and c is 0. And that's how you find a particular solution given those conditions.